This is the same graph one from the last video here. So all the same information applies. What we're going to do is we're going to start working on writing different cosine functions, and then we're going to work on writing a sine function as well. For assessments, we'll give you a graph, and you'll have to find one sine and one cosine function for the same graph, and this is kind of leading into that. Again, same points exist on this graph from the last one. This minimum down here is -4, and all the same properties exist that existed in the last example. So I'm just going to identify them, just to have them down. The amplitude was 3. That's not the A value, that's the amplitude. Period was 3.142. The angular frequency was 2, 1.999 rounded. So 2 there. The K value was -1. And those are the 4 values we really needed to work with. Now it's just a matter of picking our starting point. So this next cosine function we're going to write is going to be the same graph as the one you see on the board, same graph from the previous video. We're just going to choose our H value to start at a new location, right? So this is a high point. It starts high, it starts running low. So there's that wave right there. This is a great point right here to start for H. So H is going to equal 4.261. This next equation we're writing isn't much much more difficult, excuse me. You really can start at any of these high points if you know how to identify them, right? But we'll start at H value. So Y equals 3, right? So since my graph is starting at a high point and then running downwards like the standard cosine graph, that means my A value is negative. So I want to check in with that after I identify my amplitude of 3. So it's going to be Y equals 3 cosine of the angular frequency, which is 2 times quantity x minus your starting H value, 4.261 here, close your groups, and then add your K value, which is subtraction of 1. And that's an equivalent. That function produces the same graph. It's different than the last one we wrote, but it's technically equivalent. Just has a different starting H value, and that's what we were looking for. If you chose to start down here, right, and make your cosine function run this direction instead, where this was your starting value, well, then that means your A value is going to be negative, and you want to find you need to identify what this specific value is on the x-axis right here, which requires a little bit of work, but we're going to practice that on the next example. So we're going to on this graph work on the sine function. All these properties right here are identical, so we're going to use them. The period is not going to change, the angular frequency is not going to change, the K value line of oscillation is not going to change. The only thing that's really going to change is your H value, the fact that we're writing sine, and possibly the A value, depending on where you choose to start your graph. It's a little tricky though, right? So sine function, the standard sine function starts at the line of oscillation and runs up and then down like that. So there's some points here, right? There's this point, there's this point, there's this point. Those are all good points to start because they all start at the line of oscillation and increase first, which means your A value is positive, which is nice, but sometimes we don't have an option and we have to start maybe, with a starting point here and run down, making our A value negative. It's really up to you and how much work you want to, put into this. Remember, work smarter, not harder, but this part is a little tricky. So we did identify the period, which was from high point to high, which was 3.142, that distance right there in green. I'm looking at this and I'm noticing that a good starting point here might be right here, right? But how do I find that x value on the x-axis, right? What is this x value right there? And at first glance, it's not that hard, but the fact that we have the period is very helpful. Period measures 3.142. And I know that there's symmetry on this graph, right? So I know that halfway between this period, right there, I'm at a low point, just due to the symmetrical nature of that curve, right? You can't see it, we're just looking at this wave, which kind of resembles a cosine wave right now. But I know that halfway through this period, I can find this x value, right? Which is not a starting point for the sine function. So then if I just focus between this x value now and this section of the wave, right? The difference between this x value now, right here, and this high point value right now is going to be half the period, which we kind of identified, right? But due to symmetry, the horizontal distance right here between this x value and that point of intersection right here, right? So this distance right here is actually 1/4 of the period itself. If you think about it, right? Whole period right here. This middle line measures half the period, which represents this red portion of the curve. And then we know that this curve intersects the line of oscillation right there, and that would be 1/4 of the way through that half. So we just kind of need to find that distance, right? So let's find 1/4 of the period at this point. I think that's the best of that. So we take 1/4 of 3.142. My calculator, that's going to give me 0.7855. So I know that the horizontal distance between this minimum point and this point at the line of oscillation is 1/4 of this whole period right here. And that value is 0.7855. So that also means that the distance from this high point horizontally to the left, so this point right here is the same distance, right? So what I can do is I can subtract 0.7855 from 4.261 here, right? And that'll bring me to this x value right there. So I'm going to do that now. So it's 4.261 minus 0.7855. 4.261 minus 0.7855 gives me 3.4755. This is my h value. This is where I want to start, right here. And you were going to round this at some point, but that value right now is not a question mark anymore. It is 3.4755. And I always take a look back up to make sure, right? This high point right here is 4.261. Then this value here kind of makes sense. It's definitely less than it. So I'm pretty comfortable with the work I'm doing right now. So that's going to be our starting point, right? And then our graph is going to run from this awesome, intersection of the line of oscillation up, down, and up again, right? And then we just jump in to writing the equation. Everything else stays the same. So it's going to be y equals amplitude still +3, sine, angular frequency is still 2, open your group, x minus 3 point, let's round it to 3 decimal places since that's how everything was presented on the screen. So 3.476 another group, and then it would be plus k, and k is -1 at the moment, so we're going to write -1. And that's how we write the sine function. Now, no, it's not as easy as the cosine graph to the left, but this concept here of kind of looking at the period as a whole, looking at symmetry, splitting it in half, splitting it in a quarter to find distances to help you find, points of, starting points, right? At the line of oscillation or even down here, we could find this value here that, the difference between, this high point here and this point right here is half a period. So I can subtract half a period from that if I wanted to start a cosine function down there. But that's the work we're getting into, and you're going to practice a bunch of them for your assignment.